This is your Chapter 6C assignment video, and what we are going to do is, this is working with sample size for proportions. So the first problem is, as a newly hired manager of a company that provides cell phone service, you want to determine the percentage of adults in your state who live in a household with cell phones and no landline phones. How many adults must you survey? Assume that we want to be 95% confident that the sample percentage is within 3 percentage points of the true population percentage. Use StatCrunch to calculate the following sample size. So let's do it. Let's go to StatCrunch. There is a formula for it. Briefly, I'm going to show you that, and then we're going to go to StatCrunch. The formula is your sample size can be found by getting your critical value Z, squaring it, P hat times Q hat, all over E squared. Specifically, we would get our critical value from a table, or you could get it from StatCrunch, but for a 95% confidence level, that's 1.96 squared. P hat in this problem, we're not given any prior knowledge. This problem states that assume that nothing is known about the percentage. So when we don't know anything, our P hat is 0.5, Q hat would be then have to be 0.5, all divided by the margin of error squared. Now the margin of error here is, it says we want to be accurate within 3 percentage points, so the margin of error is 0.03 squared. Now if you do this math, you're going to get 1067.1. So let's go to StatCrunch. I prefer StatCrunch to do sample size problems. So let's do it. If we go to Stat, Proportion Stats. So the way that I know this is a proportion stats problem is simply from this word right here that says we're trying to determine a percentage. So we're not trying to find a mean or an average, but we're asked to find the percentage of adults is what we're trying to do here. So that is the key word that tells me we go to proportion stats. One sample, and this is where you go down to width/sample size because we are finding the sample size. So looking here, this is what we need to enter. Confidence level stated in the problem is 0.95 here. The target proportion. Now this is what your P hat is, but we don't have a P hat because of this right here. It says assume nothing is known. So when we don't have any prior knowledge at all, we just put 50% or 0.5 as our target proportion. And then the width, this is important, is always 2 times the margin of error. So the margin of error in this problem is 3 percentage points. So 2 times 0.03 would be 0.06, and then we're going to hit compute. So there is the sample size of 1068, and over here we got 1067.1. So what StatCrunch has done is simply rounded this up to the next the next whole number. So it changed this a little bit. You can see here from 0.06 to this value here to make this a whole number because we have to ask a whole number of people, an integer. We can't ask 0.1 of a person. So we would just simply round that up to 1068. So what does that mean? What that means is we would say to be 95% confident that the sample percentage is within 3% of the true population percentage percentage. We need to sample 1,068 households. So actually we need to add one more statement to that. So we need to sample 1,068 households. We would say with no prior information. No prior information. I'm trying to squeeze that in there because there was no information that we had to do this. But so now though, the second part of this question is we do have some prior information. We have this recent survey is suggesting that about 20% of adults live in a household with cell phones and no landlines. So we have this prior knowledge. So all that does when we compute the sample size, it just changes it a little bit because we have a starting point. So when we go over here to StatCrunch, our target proportion, now that we have this prior knowledge, becomes the 0.20. Our width, I'm just going to clear that out and type in 0.06. Again, that's since we want to be accurate within 3 percentage points, 2 times 3% is 0.06. Then we hit compute. So that's a sample size of 683. So 683. So what that really means is to be 95, so we would say to be 95% confident that the sample percentage of, I guess we would say, of households is within 3% of the true population percentage. We need to sample 683 households with the prior knowledge, with the prior knowledge that 20% of households have no landline. That's a mouthful. So sample size. It changes depending on if we have some prior information or not. So let's do one more. This is a new problem. So I'm going to underline what's important here. So it says a psychologist has developed a new test of spatial perception, and she wants to estimate the percentage. So here's the word percentage that tells me we're going to proportion stats in StatCrunch. So she wants to estimate the percentage of male pilots that will score perfectly on this test. How many people must she test if she wants the sample proportion to be in error by no more than 2 points, 2 percentage points, with 95% confidence? An earlier, so that's important too, an earlier study suggests that 65% of male pilots score perfectly. So we are just going to use StatCrunch to do this. So stat proportion stats, one sample, then we go to width slash sample size. All right, so let's do it. And of course this is always, you can find this in your notes. But let's do it. Let's just start over. I'll X out of this. We're going to go to stat, proportion stats. And again, that's from this word here that says we're going to get a sample and we want to find a percentage. So that's proportion stats. One sample, and then we go down to width slash sample size. Our confidence level, 95%. Target proportion, we do have that prior study suggesting that 65% of pilots score perfectly on this test. Now our width, that's 2 times our margin of error. So we want to be accurate within 2 points. Here's our 2 points. So that's 2%. So our width is 2 times 2%, which is 4%. So this becomes 0.04 and hit compute. So So there it is. That's our sample size. We need to ask 2,185 pilots. So let's get the sentence out here. What we got? What's 2185? So we would say to be 95% confident that our sample percentage is within 2% of the true population proportion or percentage. We need to sample 2,185 pilots with prior knowledge that 65% of pilots score perfectly. All right, that's it.